Okay, so here are 4 Hess's law problems. They're the 4 that we looked at in class, and I'm just going to walk through how I would solve them if I was given these on a quiz, on a test, on a worksheet, AP exam, whatever it might be. Again, remember, there's no specific strategy that, boom, you can solve a Hess's law problem every time. It's just kind of like a puzzle that you got to put together in the right way. So, let me look at this question here and see what we got. Calculate the standard enthalpy of formation of acetylene, C2H2, from its elements. Well, I know when elements are in their standard state, their enthalpy is 0. So I know the enthalpy of this is 0, and the enthalpy of this is 0. I'm trying to figure out the enthalpy of this. Okay? Well, I'm given some equations with the enthalpy changes for each of these reactions. Well, since I'm given all these different steps, I need to recognize that in order to figure out the enthalpy of formation of this compound, I need to make these steps add up in such a way that I get the overall reaction. This guy right here. So, my first strategy would be look at the steps. Are there any molecules in the steps that don't show up in the final reaction? Remember, those are called intermediates. So, well, let's just start with the first equation. And in the first equation, I have C graphite. No, that shows up. O2. Oh, that doesn't show up. CO2. Oh, that doesn't show up either. Both of those are intermediates, so I'm probably going to need to cancel those out. So that's something to be aware of. Let me also think about this first step. Well, the other compound I have is C graphite. It's on the reactant side. It's on the left side of this arrow here. In the overall, it's on the left side. So I'm not going to do anything to this equation. I'm just going to leave it exactly how it is because I want graphite on the left on the reactant side. What about the second equation? I have H2. Okay, that's supposed to be a reactant, so I'm not going to want to switch this one. I have O2 on the reactants and H2O on the products. Okay, well, H2O is also an intermediate that's not showing up in the overall. So this, and this are going to need to be canceled somehow, as well as the CO2. Let's look at the third equation. I have C2H2 plus 5O2, 4CO2, 2H2O. Well, first compound, C2H2. That's in the final reaction, but it's in the product side. I have it in the reactants. So I'm probably going to need to reverse this. I'm going to need to reverse it. I'm going to make a little note. I want to reverse that reaction. What else am I going to want to do? Well, I have O2, that's an intermediate, CO2 intermediate, H2O intermediate. So they're all going to need to cancel. What would I do next? Well, I need to start canceling out some of these intermediates somehow. So I want to get rid of, let's just choose one. I want to get rid of the CO2. I have CO2 in the products here and in the reactants in this equation. Oh, well, I was going to reverse step C. So let's go ahead and do that first. 4 CO2 plus 2H2O produces 2 C2H2 plus 5O2. That means that my delta H now is going to be reversed. So it's going to be 2598.8. Now if I wanted to cancel out CO2, this reaction, I only have 1 mole of it here. I have 4 moles of it here. So I'm going to multiply this whole equation by 4. Because that will give me 4 moles of CO2, which I can cancel with these moles of CO2. So let's go ahead and do that. Let's rewrite this. So this C graphite, now I have 4 moles of C. I have plus 4 moles of O2. And I now have 4 moles of CO2. So my CO2s are going to cancel. All I did to this was multiply it by 4, so delta H is now 4 times negative 393.5, which is negative 1574. Let's add these together and see what I get. So my CO2s cancel. Does anything else cancel? Well, I have 4 oxygens here and 5 over here, so I'm going to be left with 1 oxygen on the right. So I'm going to be left with 4 carbons plus 2 waters produces 2 acetylenes and 1 oxygen. Okay, so now how can I use this other step here in order to make the overall reaction? Well, I still have this O2 and this H2O. They need to be canceled. I see that I have 1 mole of O2 over here, and I have half a mole here. So that's indicating to me I need to multiply this second step times 2. So if I did that, I'm now going to have 2 moles of H2 plus 1 mole of O2 plus, producing 2 moles of H2O. Now let's add, well, what did I do? I multiplied this times 2, so my delta H for this step is going to be 2 times negative 285.8, which is going to give me negative 571.6. Let's add these together now. I have this O2 and this O2 cancel, this H2O and this H2O cancel, so I'm left with 4C plus 2H2 produces 2C2H2. Aha, that looks pretty good. The only difference is the moles up here are 2, 1, and 1. So I'm going to divide this by 2. So all these will get simplified. This will become a 2, this will become a 1, this will become a 1. So that means my final delta H, I will need to divide by 2. So my overall delta H is going to be all of these added together and then divided by 2. So 2598.8 plus negative 1574 plus negative 571.6, all divided by 2. And when I do that, I get a final answer of 226.6 kilojoules. Boom. I'm going to go ahead and solve number 3 also from that handout because this is one of the more challenging ones as well. So, again, use the thermochemical equations shown below to determine the enthalpy for the reaction. So delta H naught of reaction. That's this guy right here. Here's my overall. When I add up these steps together, they need to equal the overall. So, first thing, let's look for any intermediates. Are there any compounds in these steps that don't show up in the overall reaction? Well, let's just go with the first one. Fe2O3. Yep, I don't see that there. That's an intermediate. That's one I'm going to need to cancel. So I'm going to make a little note of it. CO, that's on the product side. Fe, oh, that's also an intermediate. It's going to need to cancel. 3 CO2s. Oh, that's here on the reactant side. So my first inclination would be to recognize that these CO2 and the CO are in the wrong spots. So I'm going to need to reverse this. They're on the wrong side. So if I reverse it, I'm now going to have 2Fe plus 3CO2 produces Fe2O3 plus 3CO. So my new delta H would be the reverse of negative 57, which would be 57.5. Let's go to my second step. My second step is right here. I have 3 Fe2O3s. Ooh, that was that intermediate again I need to cancel. CO, Fe2, 2 Fe3O4, and CO2. Again, need to cancel those out. The Fe3O4, though, is on the product side, which it needs to be here. So I'm going to leave that equation as is. I want to try to cancel out that Fe2O3, this molecule. Now the issue is I have 3 moles of it. So if I have 3 moles of Fe2O3 plus CO producing 2 Fe3O4 plus CO2, where here my delta H is still the same, negative 97.5. I didn't do anything to it. In order to get these Fe2O3s to cancel, I'm going to need to multiply this times 3, because I have 3 moles of it here and only 1 here. So I'm going to multiply this whole thing by 3. So this now becomes a 6, this becomes a 9, there's a 3 here, and this becomes a 9. That means my enthalpy gets multiplied times 3, so this actually becomes 172.5. Now let's see if I can cancel anything. Those Fe2O3s are going to cancel. I have 9 COs here and 1 here, so this would cancel and this would become an 8. I have 1 on the product here, that cancels with this, and that would become an 8. So if I rewrote what I'm left with, I'm going to have 6Fe plus 8CO2 produces 2 Fe3O4s plus 8CO. Okay, I'm getting close. Not quite there yet because I've got a bunch of extra carbon dioxides and carbon monoxides. I also have this Fe iron which needs to get canceled. Well, let's look at my last step. This last step here. Yep, there's iron, Fe, it's an intermediate, but it's on the reactant side. It needs to be on the product side because I need to cancel it with this one. So I'm going to reverse this. I'm also going to make a note of the fact that I only have 1 mole of it here and I have 6 here. So I'm going to need to reverse and times 6. So if I do that, let's rewrite it down below. I'm going to have FeO, 6 of them, times 6. This whole thing times 6 plus 6CO produces 6Fe plus 6CO2. My delta H for this step would be negative 2.5 times 6, which is going to give me negative 15. Let's add these equations together now and see what I'm left with. Well, 6 COs are going to cancel with this 8 to make 2. This 6 CO2s will cancel with these to make 2. 6 FEs, 6 FEs. So what am I left with now? I have 6 moles of FeO plus 2 moles of CO2 produces 2 moles of Fe3O4 plus 2 moles of CO. This almost looks like my original, except I need 3, 1, 1, 1, and I have 6, 2, 2, 2. So I'm going to divide this by 2 to get my final answer. So therefore, my delta H is going to be everything from here, here, and here added together. 172.5 plus negative 97.5 plus negative 15, all divided by 2. And I'm sorry I ran out of space a little bit, but if I do that, my final answer is going to be 40 kilojoules. Boom. Again, a lot of work, a lot of puzzling, a lot of thinking. What you're really trying to do, the goals, find intermediates, get them to be on opposite sides of the arrow so they can cancel, and then just make sure you keep track of whatever you do to the equation, you also do to the enthalpy. If you multiply the equation by 6, make sure you multiply the enthalpy by 6. If you reverse the reaction, make sure you make that a positive number. And I made a small mistake I'm realizing now. This was negative 2.5 and I reversed it. This needs to be positive 2.5, positive 15, positive 15. We all make mistakes. As long as we double check our work, life will be good.